Okay, I assume you've read and worked the problem now. We're going to have the next couple are going to be some area volume questions since we're far enough in the curriculum to do that. It's kind of near the end of the year. Now, there was an area volume on the test every single year until about 3 years ago or so, and then they started kind of being hit and miss, but they're pretty consistently on there, so make sure you know how to do these. So find the area of R. Well, remember, it's just top minus bottom. And this is a no calculator one. So I'll have the integral from 0 to 2 for cosine pi over 4x dx. And I'm going to split them into two integrals. Initially, I would kind of put them together at first. But notice, this needs substitution. This does not. So I'm going to have to split it into two anyway. But top minus bottom. We're going to split it into two. So I'm going to do a little substitution. U is pi over 4x. du is pi over 4 dx. So 4 over pi du equals dx. 0 becomes 0. 2 becomes pi over 2. So I have the integral from 0 to pi over 2 of 4 cosine pi over 4, for cosine of u times 4 over pi du. Okay, I'm going to go ahead and pull, well, that'll give me 16 over pi. My antiderivative would be sine u. If I went from 0 to pi over 2. Scroll down a bit. Plug in pi over 2 with sine of pi over 2 is 1, so I have 16 over pi minus 0. So I just have the 16 over pi there. So see why I had to split it into two? Because my interval changes when I use substitution. Over here it will not. It's just a good old antiderivative. Add 1, divide. Add 1, divide. 0 to 2. Plug in 2, let's see, it'll give me 8 times 2 is 16 thirds minus, let's see, 4 times 3 is 12 plus 8 and then minus 0. So I have 16 thirds minus 4. I'm going to do a common denominator. That's a minus 4. 3 over 3. So let's see, 16 minus 12 would be 4 thirds. Keep in mind you are subtracting the two integrals. So my final answer is 16 over pi minus 4 thirds. A lot of work for that one, and it's worth 4 points. Breaks down for 1 point for having the correct setup, 2 for your antiderivatives, and 1 for the final answer. Okay, part B, write but do not evaluate an integral that gives the volume rotated about the horizontal line y equals 4. Let me go ahead and take another picture of this problem because I want a better graph. Okay, it's awfully big. Let me see if I can make that a little smaller. Okay, so we are rotating about y equals 4. So right about here. So that's how it'll look there. Now remember, we are rotating about a horizontal line, which means you must be with respect to x, which we are anyway. But anytime you rotate about a line that is not an axis, you're going to have some addition or subtraction. So I have a hole in there, so I need to work on my outer and inner expressions for area. I know it's pi r squared. Okay, go to the original, don't go to your reflection here. So here's my radius to the outside. I would not really draw it over here. That kind of gets confusing. I would just draw it closer to the origin. So my radius is just that. Now this distance is 4. This distance is the function. And let's see, which function would that be? That would be my f. This is my f. That's my cosine, that's my polynomial. Okay, so I want for my radius, I want 4 minus f of x. And I could write the whole thing in there. I'm just going to kind of be lazy and write f of x. Likewise, the inner will do the same, but it's 4 minus g of x. Okay, so when I set up my integral, I'm going to take that pi out. We're on 0 to 2 still. And I have 4 minus f of x squared minus 4 minus g of x squared dx. And that was worth 3 points. 3 points. So You got 2 points for using the integrand and then 1 point for the overall answer. Okay, part C. So we have the base of the solid. Each section, cross section perpendicular to the x-axis is a square. So once again, let me grab that picture here. Okay, so we are, let's see, cross sections are perpendicular to this. So here's the x-axis. I need to be perpendicular. Okay, so I've got squares coming up going this way. Pretend those are squares. Okay, so we know the area of a square is just side squared. So my side goes from the top curve to the bottom curve. Well, we already kind of did that in part A. And that is our g of x minus f of x, right? Our cosine minus our polynomial. So my integral is from 0 to 2, side squared, which is just my g of x minus f of x squared dx. That one is worth 2 points. And like I've been doing, if g and f are defined in the problem, you don't have to write out that whole function. You can, but you don't have to.